Hello everyone, and welcome to Module 6 of INST728E on social media and crisis. In this video, we'll be talking about extracting multimedia from Twitter. This will be a relatively short video, but it'll be focused on how we identify multimedia in multimedia in Twitter messages, and how we extract them, and how we identify what are the most shared pieces of multimedia from Twitter. Now, some examples of what we'll see are images like this one. This image was posted in the immediate aftermath following the bombing at the Brussels airport in 2016. And this image was posted in the immediate aftermath of the bombing at the Boston Marathon in 2013. Now, both of these images were posted to social media. The image on the left from Brussels was actually a screenshot from a video showing people running from the airport. So what this tells us is not only is social media a powerful storytelling resource, these images were also posted very rapidly after the event. So we get storytelling essentially as the event unfolds. So in the module homework, what I want you to do is take the selected disaster that you've identified for this course, apply the module 6 notebook to it, and identify a set of powerful or highly shared images that you've been able to extract about this particular event. Now, comparatively, this is a relatively short module, so we'll go through it relatively quickly. So we come over here to our notebooks for our different modules, and we'll start up module 6. Now what we see here is a very short notebook. We only pull in a couple of things, so the typical JSON package and such that we've talked about before. We're going to add a new package for displaying HTML, which we'll see at the end of the notebook, that will let us identify a particular image that's been shared to social media and then display it within our notebook. So we'll go ahead and run this first cell, and then we have our event description. So be sure and update this to match whatever event you've been focused on. This will be our Brussels transit attack that we've been showing throughout the examples. Then we will go through and read the file containing our tweets we identified as being textually relevant in the previous module. So if you recall, the previous module talks about temporal analysis and time series, and in that module we identified a set of keywords relevant to a particular event and saved social media data that included those keywords to an external file, so we wouldn't have to reconstruct this set of relevant tweets for every module. So we'll go ahead and read in this list of tweets. In our case, this contains about 5,000 tweets, and then we'll focus on extracting the media. Now I'm going to go ahead and warn you, based on the kind of event that you've chosen or the kind of disaster you've chosen, it's possible that the imagery that we are going to extract could be disturbing. So be careful with how you share this data or where you're doing this analysis. Okay, so we've seen this before, where we have a Python dictionary that will represent our media and the relevant counts for each piece of media that's shared. And then we have some additional information that we'll save about image IDs, so we'll see that come up later. Now, the way this will work, the way we will extract media from tweets, will be very similar to how we've extracted hashtags and URLs up to this point. So that is, we'll go through our list of tweets, and then for each tweet, we'll check to see if it has a media field within its entities field. So entities is where we saw hashtags and mentions and URLs. Here we'll do the same thing, but we'll look for the media field. If there is a media field in this particular tweet, then we extract it. This could contain multiple images, not just one. This is why we call this media list. And then for each element in our list of media, so we'll go ahead and extract the media ID, which is what we'll use for counting. And then we will update the count for that particular piece of media by going to the media map, and whatever associated value for the media ID key is, we will take the default value of 0 or whatever its current count is, and we'll add 1. Then we'll update this, and then we will set the media info map for this particular piece of media ID to the media object, which contains things like URLs and thumbnails and other kinds of metadata. Now we can go ahead and run this, and it'll tell us how many unique pieces of media were shared in this data set. So we see here we have 1,000 or 1,100 unique pieces of media. Now once we have this, we can go ahead and sort the most shared pieces of media. So our media map contains media IDs as keys, and then counts as values. So we can call sorted on the map, and we'll set the key function to the get function of the media map, which says for every key in media map, sort based on whatever its value is. We'll reverse this sorted list to get the most shared media at the front, and then we can go through and print out the first 30 most shared pieces of media. This sorted media list contains IDs of pieces of media, so we'll have a media ID for each one of these elements in this list. Then we can go to our media info map and extract the media ID, and we'll get an object back that contains our media ID, the type of media, so is it a video or an image, although Twitter says all things are going to be images, regardless of whether it's images or video. How many times it occurred by looking at our media map, and then we can pull out the expanded URL. So it also contains the shortened URL and a couple of other things, but this expanded URL is what we'll actually use to display this imagery. So we can go ahead and run this, and we see that this image right here, whatever this ID is, was shared 74 times. We see a bunch of different photos. You can actually look and identify photos versus videos by looking here at this particular part of the URL. And we see this initial photo, or this most shared piece of media, was a video shared by Aaron Hive. So if we go ahead and open this, let it populate for a second, and we see it's a video of people running away from the airport after the first bombing. So we can close this out and go and look at several of these, the French cartoonist, etc. It's a little bit cumbersome to look at these images by looking at links, however. So if we scroll down to this last cell, then we have, for all of these sorted media pieces, we'll pull out the exact same thing, the media object. We can print its media ID just for informational purposes. And then we'll use the display function and the HTML function provided by Jupyter Notebook, and some simple HTML that says we'll have an image tag, and its source will point to the media URL for this particular image. So we go ahead and run this, and you'll give it a second, it will actually load as though these were all images. Now it's important to note that we used media URL instead of the expanded URL, because the media URL will tell us, or will give us thumbnail or images, not necessarily video. So if you want video, you'll have to rely on these URLs here, but at least we can view some thumbnails in a rapid way. So here are some of the images shown from the airport. This is an image from the metro station in Brussels. This is another image from the airport, and we see some cartoons and other imagery that's being shared in solidarity with the victims of the bombing. Here's an infographic talking about the bombing from BBC News, version of this image from a different angle. Now note that not all images may be available depending on how far in the past your event occurred. So you can look through the media that was shared in your disaster. So this will be what you'll do for Module 6. So essentially for Module 6, you will update your crisis info map here, just like you did in Module 5, and then run the rest of this code to extract some images relevant to your particular disaster. And as always, if you have any questions, feel free to post to Slack, and good luck.